Hello all, welcome to Excel Academy. So today we are back with another video on DSP, that is your Radix-2 DIT-FFT. Fine. So we're going to learn with respect to FFT algorithm, and we're also going to learn with respect to Radix-2 DIT-FFT algorithm. Okay. So in the case of Radix-2 DIT-FFT algorithm, you have many things, right? Like in the sense you can see this PPT. So there are many things with respect to Radix-2 DIT-FFT, right? So there are many bulk information in your textbook, but you are supposed to see that how to make use of that bulk information for your advantage. Fine? Yes. Like ಇವಾಗ ಏನಂದ್ರೆ ಇಷ್ಟು information ನಿಮ್ಮ ಯಾವ್ದ್ರಲ್ಲಿ ಇದೆ ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಇದರಲ್ಲಿ ಇದೆ. Which one? It is present in your what I can say the PPT, this PDF, I'm sorry, this PDF. Okay, so you need to understand how to make use of this, right? So ಈ information ನಾನು ಹೇಗೆ ಕಲಿಬೇಕು ನನ್ನ ಒಂದು ಯೂಸ್ಗೆ, ಸೊ ನನ್ನ ಎಕ್ಸಾಮ್ಗೆ ಈ ಇನ್ಫಾರ್ಮೇಶನ್ ಹೇಗೆ ಕಲಿಬೇಕು ಅಂತ to understand, right? So to know that, so let's come to the diagram. Let's come to FFT first. Okay, so we'll start directly with FFT. So ಏನಕ್ಕೆ ಅಂದ್ರೆ ಇಷ್ಟು information ಅಲ್ಲಿ ನಿಮಗೆ you require few of the things, or you wanted to understand this in a neat and a clean manner. So that is why I'm here to help you out. Fine? Yes. So you have, in the case of what I can say, the 4 point I'm sorry, the Radix-2 DIT-FFT and DIF-FFT, you have 4 point as well as 8 point. Okay, so this is the information regarding 8-point DFT, right? So your 4-point DFT also is there, and you might get a question on 4-point DFT also to solve in the question paper, right? So first let's discuss the basics and then come to the question paper. Okay, and I'm sorry, and in the question paper there was one question asked, right? We just saw, I guess, in the during overlap add method period or save method period, we have seen this question, right? So that is how many number of complex addition, complex multiplication, and are required to find out things, and I have seen a question, right? For that question, this is the answer. Okay, so we are also going to discuss this particular in the next session. So now let's understand what is DIT, FFT in detail. Fine? Yes, in detail. So you're supposed to first learn what is FFT. So here we are working on fast Fourier transform, right? Not discrete Fourier transform. Here we are using a methodology, say fast Fourier transform, right? So let me have that. Okay, so see my arrow mark, you can see my arrow mark, I guess. So follow the arrow mark because I'm going to showcase you things in the arrow mark and I'm going to read the same. Okay, so while I'm reading only, I guess you can find out where am I, right? Yes. So the very first thing for Radix-2 FFT algorithm states that the Radix-2 FFT algorithms are based on divide and conquer approach. So this is very much important. So see here, we are making use of, I'm sorry, we are making use of divide and conquer approach. So what is your, I'm sorry, this is very light. Yeah. Okay. So let me have my pen. Yeah. So we are working on divide and conquer approach. So what is a divide and conquer approach? Divide and conquer approach means that, see here, he has given it you in a clean manner. See, okay. So here see, the endpoint DFT is necessarily decomposed into smaller DFTs. Right? The endpoint DFT in the sense it might be any point DFT. It might be 8-point DFT, a 4-point DFT or any other point DFT. So they are decomposed into smaller DFTs. If it is an 8-point DFT, we are first going to decompose to 4-point DFT. Then that 4-point DFT gets decomposed into 2-point DFT. Fine, this is what is the procedure that you have to see, right? Yes. Because of this decomposition, the number of computations are reduced. So see, here is a point stating that because of this decomposition, the number of computations are I'm sorry, the number of computations are reduced. So what does that mean? So this means that, so by using the first Fourier transform, your computations is getting reduced. So this thing we are going to discuss with respect to that particular question what I told you before, right? Just now I told you one question stating that how much number of complex multiplication, complex additions and complex divisions are required. So I just can tell you with respect to that question. Wait a second, students. So that question was present in the just a minute. Yeah, here. So the question is, what do you mean by computational complexity? Compare the direct computation of FFT algorithm. In the direct computation of 32-point DFT of an X of n, how many complex multiplication, complex addition, real multiplication, real addition as well as trigonometric function evaluations are required? So this is the question with respect to computational complexity and is asking you how much what I can say, how many complex multiplications, addition, real multiplication, real addition and trigonometric function evaluations are required is asking. So we'll discuss with respect to that in the next session. So this is also related to some that thing itself. Okay. Yes. So now let me consider the second point. Say let my value of n be selected such that n is equal to 2 to the power of v. So what is my n? My n is equal to 2 to the power of v. Okay. So here endpoint DFT is decomposed. Just a minute. Yeah. See here my arrow mark is showcasing to you. This endpoint DFT is decomposed successively such that the smallest DFT will be of size n is equal to 2. Right? I told you, right, smallest DFT is of size and is equal to 2. What did I tell you now? I just told you that. So here 8-point DFT has been decomposed to 4-point DFT. Then it is decomposed to 2-point DFT. That means what? Your 4-point DFT. That means what? Your the last decomposition of your 8-point DFT is nothing but a 2-point DFT. So here also is telling the same. The n-point DFT is decomposed successfully such that the smallest DFT is of what? The smallest DFT is of n is equal to how much? 2. So hence this type of algorithm is called as Radix-2 or radix of these algorithms is 2. Right? So why we are calling it as Radix-2? I guess you got it. Because whenever you compose any 8-point DFT, any point DFT, n-point DFT is, I'm not telling that it is only 8-point DFT. I can tell n as any value, but that n-point DFT, that is at any value DFT is being decomposed to n is equal to 2 itself. At the last, when you decompose any n-point DFT, you will get it as 2 itself. You will get at the end 2-point DFT itself. ಯಾವುದೇ n-point DFT ನ ನೀವು ಎಷ್ಟು ಡಿಕಂಪೋಸ್ ಮಾಡ್ತೀರಾ ನೀವು ಎಂಡ್ಗೆ ಸಿಗೋದು ನಿಮಗೆ 2-point DFTs ಮಾತ್ರ, ಬೇರೆ ಏನು ಸಿಕ್ಕಲ್ಲ. ಸೊ ಅದಕ್ಕೆ we try to tell it as a Radix-2 what? Radix-2 DIT-FFT or Radix-2 DIF-FFT, or I can say that it is the radix of that algorithm as 2. Right? Yes. So now here, so let me come to this particular now. So see here, this is Radix-2 DIT-FFT algorithm. So Radix-2 DIT-FFT algorithm ಬಗ್ಗೆ ಇಲ್ಲಿ ಹೇಳಿದಾನೆ. So ನಾವು ಏನು ತಿಳ್ಕೋಬೇಕು ಇಲ್ಲಿ? So this particular Radix-2 DIT-FFT algorithm, that is 3.2, is based upon how to calculate n-point DFT of x of k. Right? So here the last equation that is given. So this is you're supposed to find n-point DFT of the x of k. That one we are going to understand, and then we are going to come to the real 8-point DFT, 4-point DFT as well as 2-point DFTs. Right? Yes. So now before that, so we'll just learn this first and then come to the original diagram. Okay. So original diagram with respect to Radix-2 DIT-FFT. So original diagram ಬಂದು 8-point DFT ಇದು ಇದೆ, 4-point DFT ಇದು ಇದೆ ನಿಮ್ಮ ಸಿಲೆಬಸ್ಗೆ. So 8-point DFT ಇದನ್ನ ನಾವು ಕಲ್ತ್ಕೊಳ್ಳುವಾಗ we'll come to that diagram. Okay. So now we are just generally discussing about n-point DFT, finding out the n-point DFT for x of k. So let's learn that first. Okay. So let's learn things in general, then come to the real. Okay. Yes. So here let's read this. So I'll read this and explain it to you. So I have made this PPT. So ನಾನು ಈ PPT ಮಾಡಿರೋ PDF ಮಾಡಿರೋ reason ಸೊ ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಇರೋದೇ ನಿಮ್ಗೆ ಹೇಳ್ಕೊಡೋಣ. ಸೊ ಇಲ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಥಿಂಗ್ಸ್ ಬೆಟರ್ ಅಂತ ಐ ಜಸ್ಟ್ ಹ್ಯಾಡ್ ಎನ್ ಐಡಿಯಾ. ಬಿಕಾಸ್ ನಿಮಗೆ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ನಾವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡುವಾಗ ನಾವು ಫಸ್ಟ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಏನಿದೆ ಅಂತ ನಿಮ್ಗೆ ಹೇಳಲೇಬೇಕಾಗುತ್ತೆ. ವಿ ಆರ್ ಸಪೋಸ್ ಟು ಟೆಲ್ ವಾಟ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಯುವರ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಂಡ್ ಹೌ ಟು ರೈಟ್ ದಟ್. ಬಿಕಾಸ್ ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲೇ ಏನ್ ಬರೀತೀರಾ ಅದೇ ನಿಮ್ಗೆ ಅದೇ ನೀವು ಎಕ್ಸಾಮ್ಲಿ ಬರೀತೀರಾ and you will get marks, right? So whatever the content is there in the textbook, you are supposed to write that. Even for theory also, ಅಲ್ವಾ? ಥಿಯರಿಗೂ ನೀವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿರೋ ಕಂಟೆಂಟೇ ಎಕ್ಸಾಮ್ ಹಾಕ್ತೀರಾ. ಸೊ ಅವಾಗ ನೀವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಏನಿದೆ ಅಂತ ಹೇಳಲೇಬೇಕು. So we are so here to tell that, right? So that is why this is my technical publication textbook where he has given things in detail. So ನಾವು ಇದನ್ನ ನಿಮ್ಗೆ ಹೇಳ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ. Okay? So in the Procalis and Monalix textbook ಏನೋ ಹೇಳಿದಾರಲ್ಲ ನಿಮ್ಗೆ, that particular textbook, what's that going to happen is you don't have that much of problems. I just had checked it once wherein you don't have that much of problems. ನಿಮ್ಗಲ್ಲಿ ಲೆಕ್ಕ ಇಲ್ಲ. ಸೊ ನೀವು ಲೆಕ್ಕ ಇರೋವಂತದ್ನೇ ಹುಡುಕ್ಬೇಕಾಗತ್ತೆ, ರೈಟ್? ಸೊ ಒನ್ಸ್ ವೆನ್ ಯು ಸಿ ದ VTU ಟೆಕ್ಸ್ಟ್ ಬುಕ್, ನೀವು VTU ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನೋಡಿದಾಗ ನಿಮ್ಗೆ ರೆಫರ್ ಮಾಡಿರೋ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನೋಡಿದಾಗ ನಿಮ್ಗೆ ಅದ್ರಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಹೆಚ್ಚಿಗೆ ಇಲ್ಲ ಅಂದ್ರೆ, ಇಫ್ ದರ್ ಇಸ್ ನೋ ಪ್ರಾಬ್ಲಮ್ಸ್, ಪ್ಲೀಸ್ ಟು ಟ್ರೈ ಟು what I can say, please to try to have a reference book. So a reference book ಪಟ್ಟಿನಲ್ಲಿ with respect to DSP, with respect to the reference list of reference book, I say that your Ganesh Rao and technical publication is the best, right? So I had already told you before also, so now also I am telling you. Why? Because I have to tell this repeatedly, because ಈಗ ಯಾರೋ ಹೊಸದಾಗಿ ನಮ್ಮ ಚಾನಲ್ ಓಪನ್ ಮಾಡ್ತಿದ್ದಾರೆ, ಈ ವಿಡಿಯೋನೇ ಅವ್ರಿಗೆ ಫಸ್ಟ್ ಸಿಕ್ತು ಅಂದಾಗ, so they'll get some information on this also, right? So according to your DSP itself, so nimge technical publication and your Ganesh Rao reference books are the best books that you can refer, right? You get more and more problems, you will have more and more understanding level will be more, right? So in the technical publication, see, you can see here, so here Radix-2 DIT-FFT algorithm pakkadallene, see it is VTU February 97, 02, 04, 05, 06, 8, 9, September 98, August 96, 05, 06, 07, 08 and 11, December 11, 12, 14, 15, June 12, 15, 16, March 99, 01. ಸೊ ಅಂದ್ರೇನು, ನಿಮ್ಗೆ ಯಾವ ವರ್ಷದಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ ಕ್ವಶನ್ ಪೇಪರ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾನೆ. ಈ ಕ್ವಶನ್ ಯಾವ ವರ್ಷದಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಅಲ್ಲೇ ಪಕ್ಕದಲ್ಲೇ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾನೆ. ಸೊ ದಟ್ ಇಸ್ ಸಮ್ ವಾಟ್ ಹೆಲ್ಪ್ಫುಲ್ ಫಾರ್ ಯು ಅಲ್ಲ. If you get to know that it is being given in VTU, so then you can easily practice it without fail, right? And don't get confused with 98, 97, 99 and all. So it is nothing but it was started in the year 97. Okay, so these subjects have been introduced in the year 97 and it is going on till now, right? 97 to 2023, you can calculate easily, right? How much? So 97 to 2007, 10 years. 2007 to 2017, 20 years. And 2017 to 18, 19, 20, 22, it is successfully 6 years it's running, right? This is the 26th year of this particular DSP subject, right? DSP subject was introduced in 1997 or before, I don't know, but 1997, but it is now it's 26th year it is successfully running this subject without any changes, right? ಚೇಂಜಸ್ ಅಂದ್ರೆ ಈ ವರ್ಷದಿಂದ ಎಲ್ಲೋ ಒಂದು ಸಣ್ಣ ಪುಟ್ಟ ಚೇಂಜಸ್ ಆಗಿರಬಹುದು, ಬಟ್ ನಾಟ್ ಮೇಜರ್ ಚೇಂಜಸ್ ಹ್ಯಾಪನ್, ರೈಟ್? ಮೇಜರ್ ಚೇಂಜಸ್ ನಾಟ್ ಹ್ಯಾಪನ್ ಇನ್ ದ ಸಬ್ಜೆಕ್ಟ್ ಅಂಡ್ ದಿಸ್ ಸಬ್ಜೆಕ್ಟ್ ಇಸ್ ರನ್ನಿಂಗ್ ಸಕ್ಸಸ್ಫುಲಿ. 26th year it is running successfully, right? So you can refer any of the question paper without fail. Okay, yes. So here you can see, I'll start reading this. So please to ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್, ಆಯ್ತಾ? ನಾನು ಆರೋ ಮಾರ್ಕ್ ಅಲ್ಲಿ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ, ನೀವು ಆರೋ ಮಾರ್ಕ್ ನ ಫಾಲೋ ಮಾಡ್ಬೋದು, ಇಲ್ಲ ನಾನು ಹೇಳೋದು ನೀವು ಕೇಳಿಸ್ಕೊಂಡಾಗ ನಿಮ್ಗೆ ನಾ ಎಲ್ಲಿದ್ದೀನಿ ಅಂತಾನು ಗೊತ್ತಾಗುತ್ತೆ. ಫೈನ್, ಬೋತ್ ವಿಲ್ ವರ್ಕ್ ಔಟ್. ಓಕೆ, ಸೊ ಹಿಯರ್ DIT means declination and time. What is DIT? DIT means declination and time. So the DIT abbreviation is told you. So this is very much important. Fine. So we are trying to tell you all this. Now ಇದನ್ನ ಏನಕ್ಕೆ ಹೇಳ್ತಿದೀವಿ ಅಂದ್ರೆ, you will understand things in a very much better manner. I don't want you to make you confused with things. I want to make you all the things clear. So that is why I'm showcasing you each and everything so that you will have some clarity, right? First of all, while studying anything, you should have some clarity, right? So that is why I'm trying to tell you, please do what? Please do watch all the videos without fail so that you will understand things in a better manner. And please do like, share and subscribe and share it to many more who are in need. And please do press the bell icon so that you get more and more updates on our channel. Right? Yes. So our motto and agenda is nothing but to make you all the things easier and to make you concept friendly as well as exam friendly. Right? You should not feel any difficulties in learning concept, or you should not feel any difficulties in understanding the proper things for exam with respect to any of the subject, right? So to avail that, please do like, share and subscribe, and please do press the bell icon to get more and more updates on our channel, right? Yes. So here DIT means declination and time. Yes. So declination and time. And okay, I'll just have a pencil. So see here, let the n-point data sequence x of n be splitted into 2n by 2 point data sequence f1 of n and f2 of n. Right? Okay. So what is our endpoint data sequence x of n? Endpoint data sequence x of n antandre x of n is given in the question itself. Your question that you get for DIT-FFT is in the form of x of n. X of n is equal to some 8-point DFT value, or I can say have one certain question wherein my x of n is equal to what? My x of n is equal to, so what is that? 4 ones and 4 zeros, right? This is also one of the question that you got with respect to the DIT-FFT in the question paper, right? So this is like, this is what is their x of n. What is telling? So let endpoint data sequence x of n. So this is what is endpoint data sequence x of n. Here this is 8-point data sequence. Here my n is 8, right? Yes. Here my n is 8-point data sequence, wherein this is what is my x of n, right? I guess you got it. So now I'll erase this. Okay. So this x of n, okay, let me have this. This is 8 point. Okay. So this x of n, you will divide it into 2n by 2 point data sequence. What is n by 2 point data sequence? Here my n is 8, right? What is 8 by 2? Which is equal to 4. So here you are dividing this 8 point, what I can say, the x of n. So 8-point data sequence, that is x of n, to 4-point data sequence, that is n by 2 is what? 4. What is your n? Your n is 8. This is 8-point DFT. So I'm considering this 8 point and I'm going to do the process now. Okay, just for explanation I'm considering this. Okay, we are going to do this question also in the further sessions, right? So ನನಗೆ x of n ಏನಿದೆ 8-point DFT ಇದೆ. ಅದನ್ನ ನಾನು n by 2 ಮಾಡ್ಕೊಳ್ತೀನಿ. So I'm going to split it into n by 2 data sequence, 2n by 2 data sequence. That is, my n is equal to 8. So 8 by 2 becomes equal to 4. So therefore I'll get it as 4. So that is why I'll divide this 8-point DFT into 2 4-point data sequence. That is 2 4-point data sequence, that is f1 of n and f2 of n. Right? Yes. f1 of n and f2 of n. So what happens is that for my 4-point DFT, so all the values of 4-point DFTs are completely f1 of n, and all the values of 4-point the next 4-point DFT is f2 of n. So let f1 of n contains even numbered samples of x of n, and f2 of n contains odd number samples of x of n, right? Yes. So here my f1 of n is containing even numbered samples of x of n, which I call it as x of 2n. So it's equal to x of 2n. And my f2 of n is containing odd number sample of x of n, which is equal to x of 2n plus 1. Right? So this particular thing I'll showcase to you. So see here, students. So here is my 4-point DFT. So see here it is. I have so this is what is my 4-point DFT, right? I'm going to divide my 8-point DFTs into 2 4-point DFTs. So 2 4-point DFT. So this is one 4-point DFT which I divide, and another 4-point DFT like this they are going to divide. So see here, I'm telling that this is n-point DFT is my 8-point DFT. So this 8-point DFT here, this is 8 point, right? This is 8 point, right? Yes. This 8 point DFT are going to divide by 2 4 point DFT, that is 2 n by 4 sequence, right? He has given what? He has given 2 what? He has given it's divided into 2 n by 2 point data sequence. So here my 8 point DFT is divided into 2 n by 2 data sequence. So this is n by 2. This is 2 n by 2 data sequences. It's been divided, and this is what I call it as my f1 of n, and this is what I call it as my f2 of n. So this f1 of n is completely consisting of even sequence, and f2 of n is completely consisting of odd number of sequences, right? Yes. So now let's come back to the original, because I had to showcase to you, so I'm having this. Yes. So then what is that is going to happen is that, so here time domain sequence x of n is splitted into two sequences. So you're going to split x of n into two sequences. So the splitting operation is called as declimation, and as this declimation is done on time domain sequence, it is called as declimation in time, right? So you're understanding things in a better manner, I guess. ಸೊ ನಮಗೆ ಏನಿದೆ, ಒಂದು ಕ್ವಶನ್ ಅನ್ನ ನಮ್ಗೆ ಅವನು ಕೊಡ್ತಾನೆ. ಅವನು ಯಾವ ಕ್ವಶನ್ ಕೊಡ್ತಾನೆ? ಒಂದು 8 ಪಾಯಿಂಟ್ DFT ಕ್ವಶನ್ ಅನ್ನ ಕೊಡ್ತಾನೆ, ಇಲ್ಲ 4 ಪಾಯಿಂಟ್ DFT ಕ್ವಶನ್ ಅನ್ನ ಕೊಡ್ತಾನೆ. ಸೊ ನಾವೀಗ 8 ಪಾಯಿಂಟ್ DFT ನೇ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳೋಣ, ಆಯ್ತಾ? ಸೊ ಈಗ 4 ಪಾಯಿಂಟ್ DFT ನ ನಿಮ್ಗೆ ಕೊಟ್ಟಾಗ n by 2 ಏನಾಗುತ್ತೆ? ಸೊ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಂಗೆ 4 ಪಾಯಿಂಟ್ DFT ದ ಕ್ವಶನ್ ಅನ್ಕೊಳ್ಳೋಣ. ಸೊ ಲೆಟ್ ಮೀ ಕನ್ಸಿಡರ್ ದಟ್ ಮೈ n is equal to 4 now. ಸೊ 4 ಪಾಯಿಂಟ್ DFT ಗೆ ನಾನೇನ್ ಹೇಳ್ತೀನಿ? 1 1 0 0 ಅಂತ ತಗೋತೀನಿ, ಆಯ್ತಾ? ಸೊ 8 ಪಾಯಿಂಟ್ DFT ನಾನು ಹಿಂಗೆ ತಗೊಂಡ್ರೆ, ಸೊ ನನಗೆ n by 2. ಸೊ ದಿಸ್ 4 ಪಾಯಿಂಟ್ DFT splitted to 2n by 2 ಪಾಯಿಂಟ್ ಡಾಟಾ ಸೀಕ್ವೆನ್ಸ್. 2n by 2 ಪಾಯಿಂಟ್ ಡಾಟಾ ಸೀಕ್ವೆನ್ಸ್ ಅಂದ್ರೆ ಏನಾಯ್ತು ನನಗೆ? n is equal to 4. ಸೊ ವಾಟ್ ಇಸ್ 4 by 2? 4 by 2 which is equal to 2, ಕರೆಕ್ಟಾ? 4 by 2 ಏನಾಗ್ತಾ ಇದೆ? 2 ಆಗ್ತಾ ಇದೆ ನನಗೆ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ? ನನಗೆ 2 ಪಾಯಿಂಟ್ DFT ಸಿಗುತ್ತೆ. ಸೊ ಅದೇ ತರ 8 ಪಾಯಿಂಟ್ DFT ನಲ್ಲಿ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ? n by 2 ಪಾಯಿಂಟ್ ಡಾಟಾ ಸೀಕ್ವೆನ್ಸ್ ಗೆ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ಒಂದು 8 ಪಾಯಿಂಟ್ DFT ನ ನನಗೆ ಏನ್ ಸಿಗುತ್ತೆ? 4 ಪಾಯಿಂಟ್ DFT ಸಿಗುತ್ತೆ. 4 ಪಾಯಿಂಟ್ DFT ನ ನಾನು 2n by 2 ಪಾಯಿಂಟ್ ಡಾಟಾ ಸೀಕ್ವೆನ್ಸ್ ಗೆ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ನನಗೆ 2 ಪಾಯಿಂಟ್ DFT ಸಿಗುತ್ತೆ. 2 ಪಾಯಿಂಟ್ DFT ನ ನನ್ನ ಲಾಸ್ಟ್. Okay? Yes. I guess you understood, right? I'm trying to tell that when you divide the 8 point DFT by 2n by 2 point sorry, when you try to divide the x of n, that is 8 point DFT into 2n by 2 point data sequence, then you are going to get it as 4 point DFT. But when you try to divide the 4 point DFT by 2n by 2 point data sequence, you are going to get it as 2 point DFTs, right? I guess you got with respect to 4 as well as 8 point DFT, right? So that is for 4 point DFT question, ನೀವು 2 point DFTs ಗೆ ಡಿವೈಡ್ ಆದಾಗ ನೀವು f1 of n and f2 of n ಅಂತ ನೇಮ್ ಮಾಡ್ಕೋಬಹುದು. Okay? Yes. And now here, and he is telling that time domain sequence x of n ಅನ್ನ ನಾವು ಎರಡು ಸೀಕ್ವೆನ್ಸ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡ್ತೀವಿ. ನಾವಿಲ್ಲಿ ಎರಡು ಸೀಕ್ವೆನ್ಸ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡಿದ್ದೀವಿ. 8 ಪಾಯಿಂಟ್ DFT ನ 2 ಸೀಕ್ವೆನ್ಸ್ ಡಿವೈಡ್ ಮಾಡಿದಾಗ 4 ಪಾಯಿಂಟ್ DFT ಸಿಕ್ತು. 4 ಪಾಯಿಂಟ್ DFT ನ ನಾವು 2 ಸೀಕ್ವೆನ್ಸ್ ಗೆ ಡಿವೈಡ್ ಮಾಡಿದಾಗ 2 ಪಾಯಿಂಟ್ DFTs ನಮಗೆ ಸಿಕ್ತು. ಕರೆಕ್ಟಾ? Yes, you got that, right? Yes. ಸೊ ಇವಾಗ ಆ ಡಿವಿಷನ್ ನಿಮ್ಗೆ ಎಲ್ಲ ಆಗ್ತಾ ಇದೆ? ಟೈಮ್ ಡೊಮೈನ್ ಅಲ್ಲಿ ಆಗ್ತಾ ಇದೆ. ಟೈಮ್ ಡೊಮೈನ್ ಸೀಕ್ವೆನ್ಸ್ ಅಲ್ಲಿ ಆಗ್ತಾ ಇದೆ. What is that happening is that splitting approach is taken place in time domain sequence. So that is why it is called declimation in time. So if anybody is trying to ask you for a general knowledge, say what is declimation in time, why it is called as declimation in time, if he is trying to ask, you have to tell that your sequence x of n is divided into two sequences. Time domain sequence x of n is split into two sequence, and that splitting is done on time domain approach. That is why we are calling it as declimation in time. Okay? Yes. So now let me erase a part of it here. Okay. So yes. Yeah. Yes. and this is now we know that endpoint DFT. ಇವಾಗ ನಾವು endpoint DFT ದು equation ಗೆ ಬರ್ತಾ ಇದೀವಿ. ಯಾಕೆ I just told you that we are going to find the endpoint DFT of x of k, right? So in general we are going to find the endpoint DFT of x of k. Then we are supposed to come to 8 point, 4 point and 2 point DFT, right? Yes, okay. So we'll learn that and we'll come to the things in a proper manner, okay? Yes, so now here the endpoint DFT is given by. So what is your endpoint DFT? ನಿಮ್ಮ endpoint DFT ಏನು? Your endpoint DFT is given by x of k is equal to summation of n is equal to 0 to n minus 1 x of n into omega n kn. This is very much important. Your endpoint DFT plays a very important role here. Okay, yes. So now this is endpoint DFT. So now my sequence x of n. So what is my sequence? My x of n sequence which is present over here. I am dividing into two sequences wherein two sequences say f1 of n and f2 of n, wherein my f1 of n is consisting of all the even sequences and my f2 of n is consisting of all the odd sequences, right? f1 of n is consisting of even number values and f2 of n is consisting of odd number samples, right? You can see, right? Here this one. So ಇಲ್ಲೇ ಕೊಟ್ಟಿದ್ದಾನೆ ನೋಡಿ n/2 ಡಾಟಾ ಸೀಕ್ವೆನ್ಸ್ ಗೆ ಡಿವೈಡ್ ಮಾಡ್ತೀರಾ ಅದು f1 of n ಮತ್ತೆ f2 of n ಅಂತ ಆಗುತ್ತೆ. ಆ f1 of n ಅಲ್ಲಿ even number samples ಇದೆ, f2 of n ಅಲ್ಲಿ odd number samples ಇದೆ, right? Yes. So now here you are supposed to use that thing and you are going to make this as n even and n odd. ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ ಸಮೇಶನ್ ಎರಡು ಸಮೇಶನ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಏನಕ್ಕೆ x of n ನಿಮಗೆ 2 ಗೆ ಡಿವೈಡ್ ಆಗ್ತಾ ಇದೆ. It's getting divided to 2 wherein which is consisting of both even and odd samples. ಅದಕ್ಕೆ ನಾನು even samples ಗೆ ಒಂದು ಸಮೇಶನ ತಗೊಳ್ತೀನಿ, odd sample ಗೆ ಒಂದು ಸಮೇಶನ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. So I'm separating the summations as even and odd sample summations. So this is a summation based on even sample wherein this x of n into omega n kn is the same. ಅದು ಬದಲಾಗಲ್ಲ. So but I am going to divide my summations into even summation and odd summation respectively. So this is summation for even. I'm sorry. Yeah, just a minute. Okay. Yes. So please do understand what I am trying to tell in a clear manner so that it would be very much helpful for you a lot, right? Yes. So idu even sequence to sample adre idu odd sequence to sample, right? Yes. So please do understand. So we are dividing the summations to even summation as well as odd summation and your x of n into omega n kn is remaining the same, right? Yes. So now here I have taken my summation as what I can say. I'll just rub this. So I guess you got it here. I have highlighted. So here it is m is equal to 0 to n by 2 minus 1. So what is m is equal to 0 to n by 2 minus 1? Yenidu summation anta andre you can see here. So my f1 of n is consisting of even number of sequence and its summation ranges from 0 to n by 2 minus 1, right? And even f2 of n also is consisting of odd number of sequence which is having the summation ranging from n is equal to 0 to n by 2 minus 1. So the value of n ranges from n is equal to 0 to n by 2 minus 1. So that is why here we are taking it as m is equal to 0 to n by 2 minus 1. Here we are taking it as m. Okay, yes. M is equal to 0 to m by 2 minus 1, right? Yes. And this is x of 2m into what I can say omega n to the power of 2mk. So ನಾವಿಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದೀವಿ ನಾವಿಲ್ಲಿ even ಮತ್ತೆ odd ಆಗಿ split ಮಾಡಿದೀವಿ summation ನ. This whole total summation is divided into even summation plus odd summation having the same. So e x of n into omega n kn having even summation and x of n into omega n kn having odd summation. So ನಾವೀಗ ಏನು ಮಾಡ್ತಾ ಇದೀವಿ ಈ even summation ದು ನಾವು range ಏನು ಅಂತ ಇಲ್ಲಿ ಬರ್ದಿದೀವಿ. What is that? m is equal to 0 to n by 2 minus 1 and we also wrote 2m here. What is this 2m? My 2m is equal to ನಾವಿಲ್ಲಿ m ತಗೋತಾ ಇದೀವಿ n ತಗೋತಾ ಇಲ್ಲ. Okay, take it as what I can say m. Don't take it as n here. Okay, so ನಾವಿಲ್ಲಿ ಹೇಳಿರೋದೇ x of 2n ಅಂತ. ಆಮೇಲೆ n is equal to 0 1 to n by 2 minus 1 ಅಂತ ಹೇಳಿದೀವಿ. ಎಲ್ಲ n ಟರ್ಮ್ ಅಲ್ಲೇ ತಗೊಂಡಿದೀವಿ. ಬಟ್ ಇಲ್ಲಿ we are coming as we are coming to here we are taking it as m terminology, right? ಇಲ್ಲಿ ಬಂದಾಗ m terminology ಹಾಕೊಳ್ಳಿ ಆಯ್ತಾ. don't take it as n. okay, here we are trying to take m terminology and here we are trying to take n terminology. okay, yes. So here we are supposed to substitute what? n is equal to 2m, right? So ಈ n ಏನು 2m. so ಇದನ್ನ ನಾವು substitute ಮಾಡ್ತಾ ಇದೀವಿ. ಇಲ್ಲಿ ಏನು substitute ಮಾಡ್ತಾ ಇದೀವಿ? so this f1 of n and f2 of n substitute ಮಾಡ್ತಾ ಇದೀವಿ. so f2 of n, f1 of n is equal to x of 2m, that is we are trying to substitute over here, and wherever in the place of n you are going to substitute 2m, right? n ಜಾಗದಲ್ಲಿ 2m substitute ಮಾಡ್ತೀರಾ, ಇಲ್ಲೂ n ಜಾಗದಲ್ಲಿ 2m substitute ಮಾಡಿದೀರಾ, ಇಲ್ಲೂ n ಜಾಗದಲ್ಲಿ 2m plus 1 substitute ಮಾಡ್ತೀರಾ, and ಇಲ್ಲೂ n ಜಾಗದಲ್ಲಿ 2m plus 1 ನ substitute ಮಾಡ್ತೀರಾ. you are going to substitute the values of n over here. so what's that going to happen? here my n become equal to, for even sequence my n is equal to 2m, right? and for my odd sequence my n is equal to 2n plus 1, right? this is what is supposed to understand, right? yes. so next step what is supposed to do? ಇಲ್ಲಿವರೆಗೂ ಗೊತ್ತಾಗಿದೆ ಅನ್ಕೋತೀನಿ. now x of n ಅನ್ನ we are trying to n point data sequence of x of n we are trying to divide it to 2n by 2 point data sequence, that is f1 of n and f2 of n, wherein f1 of n is containing all the even values and f2 of n is containing all the odd values, and my f1 of n is equal to x of 2n, which is ranging from n is equal to 0 to n by 2 minus 1, and f2 of n is equal to x of 2n plus 1, wherein your n is ranging from 0 to n by 2 minus 1, and then what we are supposed to do is we have taken your x of k, that is your endpoint DFT, and in the case of endpoint DFT you know that what is endpoint DFT, that is n is equal to 0 to n minus 1 x of n into omega n kn, wherein that summation we just divided into two parts, wherein even summation and odd summation, and wherein we got summation of n even summation of x of n into omega n kn plus n odd summation of n odd into omega n to the power of x of n into omega n to the power of kn, wherein n even ಗೆ ನಾವು ಏನು ಮಾಡಿದ್ವಿ, n even ಗೆ we just try to put the value of the summation, the range of the summation. so the range of the summation is, for even it is m is equal to 0 to n by 2 minus 1, and then in the place of n we just try to substitute it 2m there, and in the case of odd summation we just took the summation range, so that is m is equal to 0 to n by 2 minus 1, and in the place of n we just try to substitute what? we just try to substitute, that is what I can say 2m plus 1, right? yes. okay, so now in the next step what is supposed to do is, so from this particular equation, that is 3.2.1, I'll just erase this, I guess you can't see that. yeah, so this is 3.2.1 he's telling you. so from this equation 3.2.1, so what is supposed to do is f1 of m is equal to x of 2m and f2 of m is equal to x of what I can say the 2m minus 1. so this you know that, right? so hence now the above equation will become equal to, so above equation ಏನಾಗುತ್ತೆ, ಇದು f1 of n ಅಲ್ವಾ, m ಅಂತಾನೆ ನಾವು ತಗೊಳ್ತಾ ಇರೋದು. ಸೊ ಅಲ್ಲಿ n ಕೊಟ್ಟಿದ್ದಾನೆ, ಇಲ್ಲಿ ಅದನ್ನ m ಟರ್ಮಿನಾಲಜಿ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ದಾನೆ. ಫಸ್ಟ್ ಇಲ್ಲಿ n ಇತ್ತು ಅಲ್ವಾ, ಅದನ್ನೇ m ಅಂತ ತಗೊಂಡಿದ್ದಾನೆ. ಸೊ ನೋ ಇಶ್ಯೂಸ್, ಯು ಕ್ಯಾನ್ ಡೂ ದಟ್, ಫೈನ್. ಸೊ ದಿಸ್ ಇಸ್ f1 of m, right? this is f1 of m. so x of 2m ನ ಏನಂತ ಹೇಳ್ತೀವಿ, f1 of m ಅಂತ ಹೇಳ್ತೀವಿ. x of 2m plus 1 ಅನ್ನ f2 of m ಅಂತ ಹೇಳ್ತೀವಿ. so we just tell that, right? so you are supposed to substitute that, and this becomes equal to omega n the whole square k. ಇದು ಹೇಗಾಯ್ತಂದ್ರೆ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ, so ನಾವು you are supposed to write in terms of omega n kn term ಅನ್ನೋದು ಬರೀಬೇಕು. ಅದಕ್ಕೆ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ, we just took this 2 here. ಇಲ್ಲಿ 2 ಕಾಣಿಸ್ತಾ ಇದೆ ಅಂತ ಅನ್ಕೋತೀನಿ. I guess it is very much small, but yeah, just a minute. yeah. so it is omega n to the power of 2n k ಅಲ್ವಾ ಇದು. this is omega m, I'll write it in a bigger manner. omega n to the power of 2n k, right? yes, it is omega n to the power of 2n k, and here you can see that, ಸೊ ಏನ್ ಮಾಡ್ಬೋದು ಅಂತ ಅಂದ್ರೆ, ಸೊ ದಿಸ್ ಇಸ್ ಒಮೆಗಾ n to the power of 2nk, wherein what you are supposed to do is you are going to write in terms of omega n to the power of kn. ಸೊ ನಾನು omega n to the power of kn ನಾನು ಮಾಡ್ತೀನಿ ಅಂತ ಅಂದ್ರೆ, so this is I'm sorry, yeah. Yeah, so this is 2mk, right? This is omega n to the power of 2mk. So wherein ನಾನು ಇದನ್ನ omega n to the power of kn form ಅಲ್ಲಿ ಬರಿತೀನಿ ಇಂದಾಗ I will take 2 into, I'll take like this, so I'll take it as that is omega n whole square into km, right? So ನಾನು 2 ನ ಒಳಗಡೆನೆ ಇಟ್ಕೊಂಡು km ಮಾತ್ರ ನಾನು ಪವರ್ ಗೆ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. So I'm writing in the form of this, right? By taking 2 inside and keeping this k and m outside, right? And this is the same here we did, this is same here, idana now madidalva illi, yes. And here it is f2 of m. So I guess you understood things in a better manner, right? So now here I'll erase this here, okay, yes. So here in the above equation, see here in the above equation ನಾನು ಪೆನ್ಸಿಲ್ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ, ಪೆನ್ಸಿಲ್ ನಿಮಗೆ ಕಾಣುತ್ತೆ ಅನ್ಕೋತೀನಿ, ಇಲ್ಲ ನಾನು ಓದ್ತಾ ಇರೋದು ಕೂಡ ನಿಮಗೆ ಗೊತ್ತಾದ್ರೆ it is fine, okay, yes. In the above equation we have rearranged omega n factors. So omega n factors na ನಾವು rearrange ಮಾಡಿದೀವಿ, right? Yes, and we know that omega n square is equal to omega n by 2. So here we got an omega n square, wherein omega n square is equal to omega n by 2. Right? Yes. So ನಾವೇನಕ್ಕೆ omega n square whole to the power of km ಮಾಡ್ಕೊಂಡ್ವಿ, ನಮಗೆ omega n km ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬೇಕು. ಸೊ ನಮ್ಗೆ ಅಲ್ಲೊಂದು 2 ಇದೆ, ಸೊ ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, we took it as omega n square whole to the power of km, right? Which is this, right? ಈಗ ನಮ್ಗೆ ಇಲ್ಲಿ omega n square ಬಂದಿದೆ, ಈ omega n square ಬಂದ್ಬಿಟ್ಟು omega n by 2, right? So this above equation can be written as x of k is equal to, what is there, x of k is equal to, this is omega n by 2 whole to the power of km. ಎಲ್ಲ ಸೇಮ್ ಇದೆ, omega n whole square ಜಾಗದಲ್ಲಿ we are supposed to write it as omega n by 2 into km, right? Here we have written omega n by 2 into km plus what I can say, that is here you can see that this is omega, what I can say, the n by 2 to the power of km, okay. So here ಇಲ್ಲಿ ಯಾಕೆ ಇನ್ನೊಂದು omega n to the power of k ಬಂತು ಗೊತ್ತಿಲ್ಲ, but we are going to have this much, right? Yes, okay. So now this is I guess not required, leave this, fine, yes. So now here comparing the above equation, just a minute, I guess this is required, I'm really sorry, yeah. So just a minute, I'll just tell with respect to this in the further thing, okay, yes, yeah. So a minute, I'm so sorry. Yeah, so here we missed something, so let me tell with respect to that, okay. So ಇಲ್ಲಿ ಏನಾಯ್ತು, ನಾವು ಇಲ್ಲಿ ಒಂದು ಕೆಲಸ ಬಿಟ್ಬಿಟ್ಟಿದೀವಿ, ಏನ್ ಮಾಡಿದ್ವಿ ನಾವು ಇಲ್ಲಿ, ಇದನ್ನ ನಾನು ಹೇಳಿಲ್ಲ, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? I did not tell with respect to this. So see here, this is omega n to the power of k into 2m plus 1 ಅಲ್ವಾ? ನಮ್ಗೆ ಅಲ್ಲಿ ಬರೀ omega n to the power of 2mk ಇತ್ತು, ನಮ್ಗೆ ಇಲ್ಲಿ ಏನಿದೆ omega n to the power of k into 2m plus 1 ಇದೆ. ಸೊ ನಾನು k ನ I'll multiply, if I'll multiply I'll get it as omega n to the power of k, that is whole into k2m or 2km I can write, that is whole into omega n to the power of k, right? ನನಗೆ ಈ ತರ ಸಿಗುತ್ತೆ, ಕರೆಕ್ಟಾ? So that is a to the power of m plus n is equal to a to the power of m into a to the power of n ಅಂತಾನೆ ಏನೋ ಫಾರ್ಮುಲಾ ಇದೆ ನಿಮ್ಮ ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಪ್ರಕಾರ. ಸೊ ಅದಕ್ಕೆ ನೀವು ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ಸೊ ನಿಮ್ಗೆ ಈ ತರ ಸಿಗುತ್ತೆ. when you try to multiply this you get it as, you try to multiply k to 2m as well as 1. ಸೊ ನಿಮ್ಗೆ ಏನ್ ಸಿಗುತ್ತೆ, omega n to the power of k2m ಒಂದು ಮತ್ತೆ ಇಂಟು omega n to the power of k ಸಿಗುತ್ತೆ. ಸೊ ನಾನೇನ್ ಮಾಡ್ತೀನಿ, omega n to the power of k ನ ಹಾಗೆ ಇಟ್ಕೋತೀನಿ, ಬಿಕಾಸ್ ಇಟ್ಸ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ omega n to the power of kn, n ಇಲ್ಲ ಅಷ್ಟೇ, ಬರೀ k ಇದೆ, ಕರೆಕ್ಟಾ? ಎಸ್. ಅಂಡ್ ನಾವು omega n to the power of 2km ನ ನಾನು ಹೇಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತೀನಿ, I'll write it in the terms of omega n to the power of km, wherein I get my resultant as omega n whole square whole to the power of km ಅದು ಸಿಗುತ್ತೆ ನನಗೆ. ಇದು ರಿಸಲ್ಟೆಂಟ್ ನನಗೆ ಇಲ್ಲಿ ಸಿಕ್ತು. And I'll keep omega n to the power of k as it is. And that omega n to the power of k is over here. Right? Yes, I guess you understood ಹೇಗಂತ ಗೊತ್ತಾಯ್ತಲ್ವಾ. ಸೊ ನಮಗೆ ಫಸ್ಟ್ ಇದಿದ್ದು omega n to the power of 2km. ಸೊ ನಮಗೆ ಇದಿದ್ದು omega n to the power of 2km. ನಮಗೆ omega n to the power of 2km ಇದ್ರೆ ಇಲ್ಲಿ ಸಿ this omega n to the power of 2mk ಇದ್ರೆ I'll write this in a bigger manner. Yeah. So if you have omega m to the power of 2mk, if I want to write in terms of omega m to the power of n to the power of km, so I'll take like this, right? Omega n whole square into km. Then here I have omega n to the power of k2m plus 1 I have. So I have to multiply this k2, 2m as well as 1. If I try to multiply this k2, 2m as well as 1, so I am going to get my resultant as omega n to the power of k2m into omega n to the power of k. So this omega n to the power of k2m I told you, so that is k2m or 2km. I told you I am going to write in terms of omega n to the power of km, wherein I get my resultant as that is equal to omega n whole square, omega n square whole to the power of km into this omega n to the power of k, wherein I am writing this omega n to the power of k over here, right? Yes, I guess you understood things, right? Yes. So now comparing the bow equation with the definition of DFT of equation 3.22. So this is what is my 3.22 equation. So we are going to compare this equation with the 3.22, wherein you are going to get the result. We find out that the first summation represents n by 2 point DFT of F1 of m. So the first summation is telling you that I am going to get the, what I can say, n by 2 point DFT of F1 of m, right? So illenagide nimge m is equal to 0 matte n by 2 minus 1 is the summation. I guess you can see, right? It is m is equal to 0 to n by 2 minus 1. E summation n is equal to 0 to n minus 1. Here it is n is equal to 0 to n minus 1, wherein ಇಲ್ಲಿ ನಿಮಗೆ n ಇದೆ ಅಲ್ವಾ. So ಈ n ಜಾಗದಲ್ಲಿ ನಿಮಗೆ n by 2 ಸಿಕ್ಕಿದೆ ನಮಗೆ here where in the place of this n we have got here n by 2. ನಮಗೆ n by 2 ಸಿಕ್ಕಿದೆ ಅಂದ್ರೆ ಏನರ್ಥ, this is n by 2 point DFT of f1 of m ಅಂತ ತಾನೇ ಅರ್ಥ. Yes. So this is the, what I can say, the n by 2 point DFT, because ಅಲ್ಲಿ n minus 1 ಇರೋ ಜಾಗದಲ್ಲಿ n by 2 minus 1 ಇದೆ. So therefore we are trying to tell that it is n by 2 point DFT of what? It is n by 2 point DFT of, that is f1 of m, and the second summation represents n by 2 point DFT of f2 of m. n ಜಾಗದಲ್ಲಿ n by 2 ಇದೆ ಅಂದ್ರೆ it is n by 2 point DFT of f2 of m, right? Yes. So now which is equal to x of k is equal to f1 of k plus omega n to the power of k into what? x2 of k, right? X of k is equal to f1 of k plus omega n to the power of k into f2 of k, right? So this is what is they are supposed to, what I can say, log. Okay. So now ಇದನ್ನ f1 of k ಅಂತ ಬರಿತಾ ಇದೀವಿ. Why we are writing this as f1 of k? Because my DFT of f1 of m is equal to f1 of k and DFT of f2 of m is equal to f2 of k, right? That is why we are supposed to write like this. So I guess you got it till now, right? So this is only taking more and more time, students. So we are having, let us divide this into 3 parts, right? So now 8 point DFT 4 ಮತ್ತೆ 2 point DFT separate ಆಗಿ ಕಲ್ತ್ಕೊಳ್ಳೋಣ. So this one we'll finish this off and we'll wind up this session, right? Yes. So ನನಗೆ ಏನು ಅಂತಂದ್ರೆ ತುಂಬಾ ಲೆಂತಿ ಲೆಕ್ಚರ್ಸ್ ಬೇಡ, right? Don't want such a lengthy lectures, because this lengthy lectures will make you like ಇಷ್ಟೊಂದ ಅಂತ ನಿಮಗೆ ಅನ್ನಿಸ್ಬೋದು. ಸೊ ನಾನು ಪಾರ್ಟ್ ಬೈ ಪಾರ್ಟ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡ್ತೀನಿ, ಪಾರ್ಟ್ ಬೈ ಪಾರ್ಟ್ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಆಯ್ತಾ? ಸೊ ನಿಮಗೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ನಂದು ಹೆಚ್ಚು 15 minutes ನಿಮ್ಗೆ ಹೋಗಿದೆ, ಐ ನೋ ದಟ್, ಬಟ್ ದಟ್ ಇಸ್ ಒನ್ ಕಂಪ್ಲೀಟ್ ಪ್ರಾಬ್ಲಮ್ ಐ ಫಿನಿಶ್ಡ್ ಇನ್ ಒನ್ ಸ್ಟ್ರೆಚ್. ಬಟ್ ಇಲ್ಲಿ ಏನು ಒಂದೊಂದು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದೆ, ಚಂಕ್ಸ್ ಇದೆ. ಸೊ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಡಿವೈಡ್ ಇಟ್ ಟು ಚಂಕ್ಸ್ ಅಂಡ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ರೈಟ್? ಓಕೆ. So ಇದು ನಿಮ್ಮ required equation. f2 of k ಏನು, what is the DFT of f2 of m, which f2 of m. So ಈ f1 of m ದು DFT f1 of k ಆದ್ರೆ ಈ f2 of m ದು DFT f2 of k, right? right? Okay, so I'll just erase here so that I guess you can see the equation. Okay, yes. So now here my k is ranging from 0 1 to n minus 1. Okay, so now this f1 of k is n by 2 point DFT of f1 of m, and f2 of k is equal to n by 2 point DFT of what? F2 of m, right? Okay, so since f1 of k and f2 of k, so that is since f1 of k and f2 of k are n by 2 point DFTs, that are periodic with period n by 2, right? Okay, so that means that since f1 of k and f2 of k are n by 2 point DFTs, I have told you that it's n by 2 point DFT because in the place of n minus 1 ನಮಗೆ equation summation is n is equal to 0 to n minus 1 ಹೌದಾ, but ಈ n ಜಾಗದಲ್ಲಿ ನಮಗೆ ಏನು ಸಿಕ್ಕಿದೆ, we've got it as n by 2, so that is why it is n by 2 point DFT. So since they are n by 2 point DFTs, they are periodic with a period of what? N by 2. They are periodic with a period of n by 2, and then we are going to see through with respect to the equation, that is they are periodic with period n by 2, that is f1 of k plus n by 2 is equal to f1 of k, and f2 of k plus n by 2 is equal to f2 of k. So this is what, since f1 of k and f2 of k are n by 2 point DFTs and they are periodic with period n by 2, so therefore I can tell it as f1 of k plus n by 2 is equal to f1 of k, and f2 of k plus n by 2 is equal to f2 of k, right? Yes. So now hence replacing k by k plus n by 2. Hence we are trying to replace this k by k plus n by 2. So we are going to get the resultant as, so that is x of k plus n by 2. Why k plus n by 2 ಗೆ replace ಮಾಡ್ತಾ ಇದೀವಿ? Because we are telling that here f1 of k is equal to f1 of k plus n by 2 and f2 of k is equal to f2 of k plus n by 2. So then if I am telling like this, ನಾನು f1 of k ನ f1 of k plus n by 2 ಅಂತ ಮತ್ತೆ f2 of k ಅನ್ನ f2 of k plus n by 2 ಅಂತ ನಾನು ಹೇಳ್ತೀನಿ ಅಂದ್ರೆ, so my k is equal to k plus n by 2, correcta? My k is equal to k plus n by 2. So therefore I am trying to substitute k by k plus n by 2, right? So if I try to substitute k in the place of k, if I try to substitute k plus n by 2, so I am going to get it as all this gets replaced by k plus n by 2. ಯಾವ equation ಇದು? This equation is equation number 3.2.4. ನಾವು 3.2.4 equation ಗೆ k ಜಾಗದಲ್ಲಿ we are trying to substitute k plus n by 2, wherein we get this resultant, right? Yes. So now here what I am supposed to do is that I still have to take this omega of n is equal to k plus n by 2. So now here you can see that from equation 3.2.5 we know that omega n to the power of k plus n by 2 is equal to omega n to the power of k. What? Omega n to the power of k plus n by 2 is equal to omega n to the power of k. Okay, so that is here this particular thing is my omega n to the power of k. So I just replace this by omega n to the power of k. So that is minus omega n to the power of k is here. So that is why I just got this resultant, right? Here it was what? I'm sorry for the distraction. Here it was omega n to the power of k plus n by 2. This was plus omega n to the power of k plus n by 2. So I'm telling that is minus omega n to the power of k. So if I try to substitute that, so I'm going to get my resultant as what? So I'm going to get my resultant as that is equal to my this resultant, right? Okay, yes. So now here what I am supposed to do is here observe that x of k is n point DFT, correct? By taking k is equal to 0 to n by 2 minus 1, we can calculate f1 of k and f2 of k since they are n by 2 point DFTs, right? So my x of k is my n point DFT, you already know that. right? And by taking k is equal to 0 to n by 2 minus 1. So when you take your range of k from 0 to n by 2 minus 1, so you can calculate f1 of k and f2 of k since they are n by 2 point DFTs, correct? So the n by 2 point DFTs ಆಗಿರೋದ್ರಿಂದ we are trying to calculate f1 of k as well as f2 of k easily, right? Yes. So now the endpoint DFT x of k can be combinedly obtained from equation 3.2.4 and 3.2.6 as, so this is 3.2.4 equation, right? So we are going to take the range from k is equal to 0 to n by 2 minus 1. So this is one particular resultant, right? Yes. So this is one particular resultant. This equation is I'm sorry students. So this equation is the same equation as the same equation, that is 3.2.4 equation only. But what I'm supposed to do is that you're going to have the range of k from 0 to n by 2 minus 1. So that is why this equation is once again named as 3.2.7, right? Equation 3.2.4 in it. But now when we are taking the range of k is equal to 0 to n by 2 minus 1. ಅದಕ್ಕೆ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, so I am trying to what I can say have what rename this equation as 3.2.7, right? Yes. So now coming on to x into k plus n by 2. So what's that going to happen is that, so that is f1 of k minus, so this is x of k plus n by 2, this one, okay, this particular, which one, this 3.2.6. So this equation will be is equal to this particular, wherein we are going to name it as 3.2.8, right? So these two equation is trying to tell me what? It's trying to tell me that my endpoint DFT can be obtained by 2n by 2 point DFTs, right? So ನಿಮ್ಮ endpoint DFT ಬೇಕು ಅಂತಂದ್ರೆ ನೀವೇನ್ ಮಾಡ್ಬೋದು, 2n by 2 point DFTs ಇಂದ ನೀವು x of n ಅನ್ನ ಪಡ್ಕೋಬಹುದು, endpoint DFT ನ ಪಡ್ಕೋಬಹುದು ಅಂತ ಇಲ್ಲಿ ಹೇಳಲಾಗ್ತಾ ಇದೆ. So it means that, so in the I'll showcase you the diagram, okay? ಈ equation ಪ್ರಕಾರ ಅರ್ಥ ನೀವು ಎರಡು n by 2 point DFTs ನ ಉಪಯೋಗಿಸಿದ್ರೆ n point DFT ಬರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ದಾರೆ, ಕರೆಕ್ಟಾ? So I'll show you in a practical manner. So see here, this is my 8 point DFT, fine? So now here, if I want 8 point DFT ನನಗೆ ಸಿಕ್ಕಬೇಕು ಅಂದ್ರೆ ನಾನು ಏನು ಮಾಡ್ತೀನಿ, 8 point DFT, that is x of n, I'll divide it into 2 n by 2 point sequence. So n by 2 point sequence ಅಂದ್ರೆ ಏನಾಯ್ತು, 8 by 2 ಏನಾಯ್ತು, 4 ಆಯ್ತು, ಕರೆಕ್ಟಾ? So 2 under 2 4s ಆಯ್ತು, I got 4 point DFT. So ನಾನು 2 n by 2 point DFT ಗೆ ಡಿವೈಡ್ ಮಾಡಿದೆ ಅಂದ್ರೆ ಏನಾಯ್ತು, I'll get 2 4 point DFT, right? So I have my 8 point DFT, say x of n, I'm going to divide it into 2 n by 2 point sequence. So ನಾನು 2 n by 2 point sequence ಮಾಡಿದ್ರೆ as my n is equal to 8, I'll get it as 4, right? I'll get it as 4 point DFT. So 2 4 point DFT ಸೇರಿದ್ರೆ ಏನಾಗುತ್ತೆ, 8 point DFT ನೇ ಆಗೋದು, ಕರೆಕ್ಟಾ? So that is why we are trying to tell that you're going to get the n point DFT by what? by combining 2 n by 2 point DFT. ಅಂದ್ರೆ ನಿಮ್ಗೆ 8 point DFT ಬೇಕು ಅಂತಂದ್ರೆ 2 n by 2 point DFT ನ ಕ್ಲಬ್ ಮಾಡಬೇಕು, ಅಂದ್ರೆ 2 4 point DFTs ನ ಕ್ಲಬ್ ಮಾಡಬೇಕು. Here you can see the 2 4 point DFTs are clubbed together. So this 4 point DFT is clubbed together. This 4 point DFT and this 4 point DFTs are clubbed together over here. 2 n by 2, that is 4 point DFTs are clubbed together, wherein you get 8 point DFT. So hence proved, right? Yes. So this is what I was about to tell you in this session, students. Okay. So I guess you understood what I was trying to tell you. So this equation is what? This equation is the same as 3.2.6 itself. 3.2.6 ane, but now k ಗೆ range ಕೊಟ್ಟಿರೋದ್ರಿಂದ we have named it as a different equation, right? And this two equation is trying to tell me that n point DFT can be obtained by 2 n by 2 point DFTs, right? Okay. So we have here also proved that ನಿಮಗೆ ಒಂದು 8 point DFT ಬೇಕು ಅಂದ್ರೆ 2 4 point DFT ಕ್ಲಬ್ ಆದ್ರೆ ಸಿಗುತ್ತೆ ಅಂತ ನಾವು ತೋರಿಸ್ಕೊಡ್ತೀವಿ. Okay. So now here in this particular session we just discussed with respect to how to find out n point DFTs of x of k, and we also proved that how how endpoint DFTs can be found out by using 2n by 2 point DFTs, right? We have told in the beginning itself we are trying to divide x of n into 2n by 2 point DFTs. Again, ನಾವು divide ಮಾಡ್ತಾ ಇದೀವಿ x of n ಅನ್ನ ಅಂತ ಹೇಳಿದೀವಿ, correct? So that one we are trying to prove it, right? When you divide that and when you club that again, so you're going to get the same endpoint DFT resultant ಅಂತ ನಾವಿಲ್ಲಿ ತೋರಿಸಿದೀವಿ. Okay, so this is just for your general knowledge and understanding, right? So now understanding goskara idannella ಹೇಳ್ತಾ ಇದೀವಿ, but still next you are going to have your things in detail, right? Yes, so this is the basic diagram. So let me show you once the basic diagram ondsati ಹೇಳಿರ್ತೀನಿ, then we'll move to in detail, right? So this is my 8 point DFT diagram. So idu ನಿಮ್ಮ 2 point DFT. So 2 point DFT ಇಲ್ಲಿ 4 ಇದೆ. So these 4 2 point DFTs are getting clubbed together to form 4 point DFT, and these two 4 point DFTs are getting clubbed together to form 8 point DFT, where you can see here, right? So ಇಲ್ಲಿ ಏನಾಗಿದೆ ನಿಮಗೆ reversed order ಇದೆ. So it is in a bit reversal order. So ನಮ್ಮ input ಅನ್ನ ಏನು ಕೊಡ್ತೀರಾ, bit reversal order ಆಗಿ ಕೊಡ್ತೀರಾ, and your output you will get it in an orderly manner, right? So this bit reversal order also I am going to explain it to you in the next session. Okay, and when you give this, you are going to get this resultant in terms of v. ಈ v ನ ನೀವು ಇಲ್ಲಿ ಕೊಟ್ಟಾಗ ಸೊ ಮತ್ತೆ ಇದು ಏನೋ ಪ್ರೋಸೆಸ್ ಆಗಿ ಮತ್ತೆ f ಅಲ್ಲಿ ರಿಸಲ್ಟೆಂಟ್ ಬರುತ್ತೆ, and I'll erase this. So see here, yeah, see, when you try to solve this, you are going to get the resultant in terms of v, ಮತ್ತೆ ಇದನ್ನ ಕೊಟ್ಟಾಗ f ಅಲ್ಲಿ ರಿಸಲ್ಟೆಂಟ್ ಬರುತ್ತೆ, ಮತ್ತೆ you will get this x of 0 DFT, right? Yes, so now we'll wind up the session for here. So because ನಿಮ್ಗೆ ಇದನ್ನು ಲೆಂತಿ ಆದ್ರೆ ತುಂಬಾ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತೆ, so I'll have another 2 separate sessions, or let me try to finish in one session itself. So I'll share you another video on this so that you will understand how to solve 8 point DFT, 4 point DFTs and 2 point DFT. So ನಿಮಗೆ ಹೇಗೆ ಏನು ತಿಳ್ಕೋಬೇಕು ಇಲ್ಲಿ ಅಂದ್ರೆ, ಈ v11 of 0 ಏನು, ಈ v11 of 1 ಏನು, ಈ v12 of 0 ಏನು ಅಂತ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. You have to understand what is that and how you have to find that. Okay, ಸೊ ಅದನ್ನ ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು ಅಂತ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಅದನ್ನೇ ನಿಮಗೆ 8 point DFT, 4 point DFT ಮತ್ತೆ 2 point DFT ಲಿ ಹೇಳಿದ್ದಾನೆ. ಸೊ ಅದನ್ನ ನಾನು ನಿಮಗೆ ಕ್ಲೀನ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಮಾಡಿ ಕೊಡ್ತೀನಿ, so that you will understand in a very better and a clean manner, right? And then let us do with the example. So ನಿಮಗೆ ಎಕ್ಸಾಂಪಲ್ ಮಾಡಿದಾಗ ನೀವು ಇನ್ನೂ ಸ್ಟ್ರಾಂಗ್ ಆಗ್ತೀರಾ, right? You will become more and more strong on how to solve that. And ನಿಮಗೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ಅಲ್ಲಿ ನಾನು ಎರಡೇ ಮಾಡೋಕೆ ಸಾಧ್ಯ. ಒಂದು a simple example, that is 4 ones and 4 zeros, which I told you now, and the other one that is with respect to the question paper. ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಮಾಡ್ತೀನಿ, ಒಂದು ಸಿಂಪಲ್ ಮಾಡ್ತೀನಿ. So if I try to do with respect to this complex, so let me go to this one. Okay, here you can see I have taken one question paper with respect to yeah. So ಇಲ್ಲಿ ನಿಮಗೆ this kind of question is there for you. X of n is equal to n plus 1. I told you, ನಾನು ಇದನ್ನ ಒಂದ್ಸಲ ಡಿಸ್ಕಸ್ ಮಾಡುವಾಗ module 2 ಕಂಪ್ಲೀಟ್ ನಾನು ಹೇಳಿದ್ದೆ ಏನಂತ, n ಗೆ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, n ಗೆ 0 to 7 ಅಂದ್ರೆ to substitute the value from 0 and n till 7 and x of n ಏನ್ ರಿಸಲ್ಟೆಂಟ್ ಬರುತ್ತೆ ಅದಕ್ಕೆ ಸಾಲ್ವ್ ಮಾಡಿ ಅಂತ. And I'll have another I'm sorry, another question paper, so that it would be very much helpful. So ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಕ್ವಶನ್ ಬಂದಿದೆ, ಅದನ್ನು ತೋರ್ಸಕ್ಕೆ ನಾನು ಟ್ರೈನ್ ಟು just a minute. Yeah, see 1111 and 0000, this one I told you, right? Yes, and now let me come to the other one. Wait a minute. So okay, so ಒಂದು ಕ್ವಶನ್ ಪೇಪರ್ ಅಲ್ಲಿ ನಿಮಗೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕ್ವಶನ್ ಬಂದಿದೆ. So if you get a complex question with respect to what I can say this DIT-FFT, so I'll just show you the complex question. So this complex question is what? The complex question is points allo question ಬಂದಿದೆ, ಅಂದ್ರೆ points question ಅಂದ್ರೆ ನಿಮಗೆ 0.5 0.5 0.5 4 0.5 and 4 zeros, right? So ನಿಮಗೆ ಯಾವ್ದನ್ನ ನಾನು ಮಾಡಬೇಕು ಅದನ್ನ ಮಾಡ್ತೀನಿ. If which one I can't just showcase you on board, I'm going to have the textbook, ಅದನ್ನ PDF ನಾನು ಮಾಡ್ಕೊಂಡು I'll just showcase to you, fine? So actually this I can't write this whole butterfly diagram here. ನಾನು ಬರ್ದು ಅದನ್ನ ಕ್ಲೀನ್ ಆಗಿ ತೋರ್ಸಕ್ ಆಗಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ಐ ಜಸ್ಟ್ ಟ್ರೈ ಟು ಹ್ಯಾವ್ ಅ PDF ಆಫ್ ದ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಂಡ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಇಟ್ ಇನ್ ಎ ನೀಟ್ ಮ್ಯಾನರ್, ರೈಟ್. ಅಲ್ಲಿ PDF ಅಲ್ಲಿ ನಿಮಗೆ ಬರ್ದಿರ್ತಾರೆ ಅಂತ ದಯವಿಟ್ಟು ಅನ್ಕೋಬೇಡಿ. ಅದನ್ನ ನಾನು ಮತ್ತೆ ತಿರ್ಗಾ ಐ ವಿಲ್ ಟ್ರೈ ಟು ರೈಟ್ ಇನ್ ಮೈಕ್ರೋಸಾಫ್ಟ್ ವೈಟ್ ಬೋರ್ಡ್ ಅಂಡ್ ಶೋಕೇಸ್ ಯು, ರೈಟ್. ಸೊ ಇಫ್ ಯು ಗೆಟ್ ಅ ಕ್ವಶನ್ ಆನ್ this complex, so complex to ಒಂದು question ಇದೆ here. See, this is what is the question. So my complex question is, so that is just a minute. Yeah, so 0.707 comma 1, 0.707 comma 0 minus 0.707 comma minus 1 comma minus 0.707 comma 0, right. So this is what is the question that you have got. So ಈ question ಅನ್ನ ನಾವು ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ. Okay, so it is like in the sense, so what you're supposed to do is, just a minute, I'll just clarify things for you all so that it would be very much better. So ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ, ಸೊ ನಿಮ್ಗೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕ್ವೆಶನ್ಸ್ ಅಂತ ನಾನು ಹೇಳಿದ್ದೆ, ಎಲ್ಲಾನು ಕಾಂಪ್ಲೆಕ್ಸ್ ಕ್ವೆಶನ್ಸ್ ಏನೆ. ಐ ವಾಂಟ್ ಟು ಟೆಲ್ ಯು ದಟ್. ಸೊ ವೈ ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಅ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕ್ವೆಶನ್ ಇಸ್ ಬಿಕಾಸ್ ಎಲ್ಲಾನು ನಿಮ್ಗೆ ನ್ಯೂಮರಿಕ್ಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರಬಹುದು. So it's given you stating that 1111 and 0000, right. So ಇದು ಕೊಟ್ಟಿದ್ದಾನೆ, but when you try to do the process, ನಿಮಗೆ process ಮಾಡುವಾಗ your J terms get added automatically while doing the process, right. Your J terms get added automatically while doing the process. So therefore I am trying to explain it to you in a clear manner in the upcoming sessions, right. So see here, please to understand. So ಈ diagram na ನಾನು ಬರೆಯೋಕ್ಕಾಗಲ್ಲ. I can't write and showcase to you in the whiteboard. So I'm trying to have my textbook as a PDF and I'm going to showcase you each and everything in the textbook and explain it in a clear manner so that it would be very much helpful for you. Okay, so ನಾನು ಯಾವುದನ್ನು ಬಿಡಲ್ಲ, ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ತೋರಿಸ್ತೆ ಅಂತ ಅನ್ಕೋಬೇಡಿ, ಯಾವುದನ್ನು ಬಿಡಲ್ಲ. I'll just make sure that I'll just teach each and every small things in a clean and a neat manner so that it would be very much helpful for you, right. And once I'll showcase to you in the Microsoft whiteboard or any other thing how to draw this particular diagram. Okay, so first ನಿಮಗೆ ಇದನ್ನ ಹೇಗೆ ಡ್ರಾ ಮಾಡಬೇಕು ಅಂತ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ, ಸೊ ನಿಮಗೆ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಕ್ವೆಶ್ಚನ್ ತೋರಿಸಿ ಹೇಳ್ಕೊಟ್ರು ಗೊತ್ತಾಗುತ್ತೆ. So you need to first know how to draw this diagram. So that one I am going to explain it to you in a clean and neat manner. So this diagram drawing, this particular is all the same, but what you're supposed to do is that you're supposed to just what I can say, question takkange nimge answers change agutte, but this diagram for all the question it is the same, right. So this is what I was about to tell you, students, and let's meet in the next session. I'll continue this session after some time and I'll just provide you another session for you wherein I'll provide this today itself because you have to learn this two in one go, ರೈಟ್. ಇದೆರಡನ್ನು ಒಂದು ಗೋನಲ್ಲಿ ಕಲಿಬೇಕು. ಸೊ ಹಾಗಾಗಿ ನಾನು ಇವತ್ತೇ ಸೆಷನ್ ನಿಮಗೆ ಖಂಡಿತ ಕೊಡ್ತೀನಿ. And this is what is for today, this particular session, and thank you.